Let's get started here. So we have another day of chain rule. Really just learning about. That was exciting, right? Except they're going to do some logarithmic and exponential functions. Some very basic stuff that you do need to know as we go through this. Because it's going to help you out a lot. Trust me. Because it can help you with some shortcuts. First off, anybody remember how to rewrite a log into an exponent? Base is a base. Wow, that sounds pretty easy. Okay, and a to the y equals. Has anybody ever? Do you know what the loop is? I don't know if I do it at the school. No one at the school has done a loop. So you start here. A to the y equals x. Yeah. Hopefully I just looped your brains. Okay, so for the first one, log base a of 1 is equal to 0. We need to know these rules. If I have log base a of xy, is there a way to rewrite it? By the way, I write my L's cursive because I don't want my L's to look like 1s. So log base a of x plus log base a of y. All you're doing is rewriting a product into a sum. What about if it's a division sign? It's going to turn into a minus. Log base a of x minus log base a of y. What if there's an exponent? It comes in front and multiplies, so it's n times log base a of x. So, two logarithms you must know. Essentially, the ln has a base of what? E. Very good, class. So if the base ever matches the inside function, the answer is always going to be what? It's going to be 1. It's going to cancel out to be 1. So ln of e is always 1. If I had like log base 2 of 2, what would that be? That'd be 1. Log base 3 of 3. Log base Neelish of Neelish. It's 1. What's ln of 1? 0. So any type of log. This one's different, Neelish. This is any log of 1 is equal to 0. So like log base 2 of 1 is 0. Log base Neelish of 1 is 0. Okay, let's practice expanding these. So, quiet please. So I look for how many things are multiplying. How many things are multiplying or dividing? 1, 2, 3 things. So how many ln's am I going to have now? I'm going to have 3. What's my first ln? 2 plus ln of x to the 4th. I'll deal with that in a second. Plus ln of okay, now after I expand everything, I like to do my exponent rule. So was my exponent rule apply to any of these? Which one? Or ones? The middle one? And the last one. What's the exponent right here? Exponent of 1/2. So ln of 2 plus 4 ln of x plus 1/2 ln of 3x plus 2. I have to wrap it up because it's not just ln of 3x and then a plus 2. It's ln of all of it. You get the idea. Do I really need to do the next one? Of course. Okay. How many things are multiplying or dividing? 1, 2, 3. I'm going to have 3 of these. So I'm going to have ln of x squared plus 3 all squared minus ln of x to the 3rd plus minus, what is it? Why is that a minus? But coach, it's multiplying on the bottom. Well, it's on the bottom, so it's a minus. Loser. Okay, does my exponent rule work here for one of them, two of them, all of them, none of them? All of them. Let's do it. So 2 ln of x squared plus 3 minus 3 ln of x minus 1/2 ln of x squared plus 1. Yay, logs. What's up? You know what? You might be right. You might be right. I do not know. The person that created this clearly did not state what they wanted. That's all I can tell you. I took that for x to the third. I probably am wrong now I'm looking at it again. Because that 3 looks like it's over the square root. But let's just pretend that that's how I took it. No, they're going to say that it was supposed to be a cubed root because the little 3 is over the square root. But it's not the most clear thing in the world. Like, this should have been written as x times cubed root, or at least that much space in between. It should have been written like that, but it wasn't, so. Who wants to take some derivatives? Nope, not at all. Hey, this stuff's easy. Okay, first off, I'm going to do these rules last because I care about this a little more. So the derivative of ln of x is 1 over x. The derivative of ln of x is 1 over x. That's a big rule. Okay? Now, when I take the derivative of ln of a function, U represents like a function, like x squared plus 1, that's a function, or something weird like that, not just a plain x. You would have to use chain rule, wouldn't you? Alright? So you would do the derivative of the outside. What's the derivative of the outside here? What's the derivative of ln of u? Which the outside would be just 1 over u times, what's the derivative of the inside? We're just going to note it as u prime. So this is equal to u prime over u. I never use it this way. I always think chain rule, and I always write it out like this, the bottom one. But, hey, that's more formulas. Do you like more formulas? I don't. I like teaching you how to do things one way, and then it applies to everything. Okay, let's go to the left here. This one's kind of a weirder one. Okay, I'm going to do, first off, the simple derivative. So, of log a of x. This is going to be 1 over ln of a times x. That's the derivative of, so we have a base, it's 1 over ln of whatever that base is times x. So for instance, I'm not going to do this example because you'll never see that again. What's the derivative? I want to do some simple ones. Derivative of log base 2 of x. What would that be? One over ln of times x. Some people will write that as 1 over x ln of 2. Doesn't really matter what order you put it in. Okay? So now if you had to chain rule it, this would just become the derivative of the outside would be 1 over ln of a times, u times u prime. And I'm going to put all of these formulas to use because I'm sure staring at them you're like, I don't know. You're better off just doing chain rule, figuring it out. Okay, so for number 1, I'm just going to walk you through all of it. Pay attention. So, find the derivative for y prime. This is an ln. So I'm going to do the derivative of the outside, which is just 1 over whatever the original is, times the derivative of the inside, which is 2x, that's the correct answer right there. If you want to make it look pretty, 2x over x squared plus 1. This absolute value thing, it doesn't matter at all. It does not matter. You want to know why? What's the domain of an ln function? Isn't it from 0 to infinity? Is that what you said, Neelish? No, nice! So why does the absolute value not matter then? It's already all positive. So I don't even know why they do this. I don't even think they do it in the AP, to be honest with you. They did it a long time ago. Okay, so now let's go ahead and do this one. So this one is going to be, well, you tell me. What's the first thing you do? What's the derivative of the ln function? 1 over cosine times, what's the inside? Negative sine of x. Rewrite it because it's trig, so I bet you that won't be the answer. Negative sine over cosine, which is? It's beautiful. It's beautiful. All right, number 3. Ruh-roh. That's product rule, isn't it? We can do it. So, what's the derivative of the first? Leave the second plus leave the first. What's the derivative of the second? 1 over x. Rewrite it now and make it look pretty. ln of x plus 1. Are we following along? I'll find out in a second here. Okay. Why don't you try number 4? I'm going to give you about a minute and a half to try number 4. So go ahead and try it. I'm going to call on a random person. Any one of you. You're all fair game. Except for Jason. Not you, Jason. Other Jason. The Jason that is not even paying attention. He doesn't know I'm saying his name. He has no clue. Jason, what you watching over there? Oh, who is it? I don't think I know who that is. What movies is he from? He doesn't do TV either. I started watching the Ozarks.
Oh, I tried that. I watched like 3 episodes.
I'm at 3 episodes.
I couldn't get it.
It was a good start. It's slowing down now. I'll power through it though. Talk to a partner. See what they're getting. See if they match you. Alright, let's bring it back up here. I heard some discussion where some of you are like, we gotta move this 3 in the front. You actually can't do that. You quit calculus? This is basic math. It's not x cubed. If it was x cubed, I agree with you. But what's being cubed? The ln function's being cubed. I have seen this notation, not very often, but I have seen it written like this. Like, you know how they put like the cubes in the middle of the cosines and the sines and the trig stuff like that? I've seen it written like that. So it's kind of the same idea here. Okay? So that's not step one. I'm just showing you that the notation can be different. Okay? So who am I gonna call in here? Julia. 3 ln x all squared. 3 ln. Oh, you did the same thing they did? Yeah, okay. That might be right. Is that what you did or no? You forgot the parentheses. Alright, what's the derivative of the outside? Isn't it 3 inside squared? So 3 inside squared times, what's the derivative of the inside? 1 over x. So it's this times 1 over x, which is actually that. Beautiful job, Julia. I don't know if your notation was correct, but the answer. Alright, let's look at 5 real quick. We're going to start to use some of our log properties because I don't feel like doing this one. Right? This one's kind of weird because you have to do like 1 over root x plus 1, then do the chain rule of that. We don't have to do that for the ln stuff because we know this lovely property, the one that Emily tried over here, which is we can do what with the square root? This is equal to ln of x plus 1 to the 1/2. What can you do with that 1/2? So this is really 1/2 ln of x plus 1. Isn't this much easier to do now? So you're going to get 1/2, so this is f prime. Is going to be 1/2 times, well, it's going to be 1 over x plus 1, and what's the derivative of the inside? Times 1, which is just 1 over, make sure you wrap that up, which is that right there. Much simpler than going through the whole chain rule idea. So let's use some of these laws to do 6. Why don't you try 6 on your own? Use the laws. Use the laws. Alright, let's kind of go from here. I mean, if you have ln of 2x, it's not going to matter, because it'll cancel out anyway. Because real quick, the derivative, if I have ln of 2x, you want to find the derivative of that? It's going to be 1 over 2x times 2, which is just 1 over x. It'll cancel out itself. So this is going to be the derivative of ln of 2. Oh my god. Oh my god. What's the derivative of ln of 2? What's the derivative of a number? Zero! Thank you, Neelish. You saved me from a heart attack. You almost didn't have a teacher. So the ln of 2, the derivative is 0. 2 is a constant, not a variable. What's the derivative of ln of x? Minus. What's the derivative of ln of x plus 3? Boom. Don't need to combine it. Let's go down to 8. I feel like we don't need to do all these problems. I don't want to just kill you with problems. I'd rather have you do problems and not you watch me do problems. So number 8. I'll walk you through it. Why is this one a little bit different? It has a base of 5. That's not going to change anything. Can I do a rewrite first? What's my rewrite going to be? Log base 5 x squared minus 1 minus. Okay. So the derivative of the first one. So let's rewrite the original. So it's going to be 1 over ln of 5 times x squared minus 1 times, what's the derivative of the inside? (2x) minus, what's the derivative of this guy? I mean, I can rewrite it a little bit, but there's not really much going on for a rewrite here. So it's going to be 2x over ln of 5 x squared minus 1 over ln of 5 times x. Alright, we good? I know there's like a bunch of derivative rules and everything. I'll try to get you like a printout of everything we've done so far in terms of stuff that you need to know. And it would have like IVT on it and continuity definition. I'll try to get you like everything we've done. Alright, try 10 on your own. This one's tangent line. See if you remember how to do this. Well, see if I can find something to print out. How do we do? You got it right? Nice. Oh, don't take it away. I'll leave it up here. All right, talk about exponent. Hey, I'm going to tell you what the derivative of 3 to the x is. And you're going to tell me what the rule is. Okay? Here's the derivative of 3 to the x. It's going to be ln of 3 times 3 to the x. What just happened? What do you think 2 to the x is going to be? Okay, so you all know the pattern. You see it. You clearly see the pattern. So what do you think the definition is going to be? So if the base is a, I'm going to have ln of a times the original. U is some function, and then whatever that derivative of u is. So in this case, the inside function was an x, so the derivative of x is just 1. So that's why I didn't write it out. Okay. So, like, the definition I like better than that. I like the basic stuff better. So if it was like a to the x, this would be equal to ln of a times a to the x. So we can kind of rewrite this one though. So let me do d over dx of e to the x. It's the same exact thing. What would it be? Same exact thing as this. It would be ln of, let me know if you're saying it. What is the ln of e? It's 1, so the derivative is e to the x. The derivative of e to the x is e to the x. This is why e to the x is so special. Whatever coordinate point you're at, the height of it is equal to the rate of change of it. So, like if I were to draw e to the x, so this was e to the x, right? If this value at 1, what's the height of e to the x at 1? E. Just plugging in a 1. So the height would be e, and the slope would also be e. It's amazing. So anyway, the derivative with that function is going to be e to the u times u prime. Let's just do some problems, because I don't like how they have the expanded definition. Not a fan of that. Let's just do this one right here. So, okay, let's find y prime. So, anytime you have an e, you're just going to rewrite it. So, the derivative of e is, inside stays the same, times with the derivative of the inside. It's 2. Boom, you're done. This goes a lot faster than the log stuff. For number 12, what are you going to get? Y prime is equal to e to the root x times, what's the derivative of? Like that. I'm going to rewrite it so that they're all square roots. Try 13 on your own. Calling a random person. right, Mason, what'd you get? Do you agree with him? Wow, where's that confidence? Is this what you got? Yes? Cool. Do I need to keep working these EDX problems, or do you think we're good? I mean, that's probably how it would look multiple choice. Let's do 16. So we have work 16. What's the derivative? Now the base is 7. Base is 7. So how do I write this now? I used to just go like, hey, e to the whatever right away, but I need to do an extra little tiny thing. What's the first thing I have to write down? ln 7, thank you, whoever said that. ln 7 times 7 to the 3x plus 1. That's the derivative of the outside. That's 7 to the whatever it is. Times, what's the derivative of the inside? 3. And that's the answer. 3 ln 7 times 7 to the 3x plus 1. I have seen them be complete jerks with this one and write down the answer as on his multiple choice. What would this one be? ln of 343 times 7 to the 3x plus 1. How did that happen? I put the 3 on top of the 7, so the 7 in the third. I've seen it written like that before as answers. Do you want to do 17 or 18? It doesn't matter. I mean, because I have like a whole worksheet, like it's like chock full of this stuff. It doesn't matter to me one way or another. You just want to do the worksheet? I'm gonna look through and see what problems I think that are good. That nothing here is new, so I'm not too worried about it. All right, we just did an equation on line 1. Not worried about it. I do want to come down here though. 23, because you struggle with these. Okay, so now do you see a limit? Does this look like a regular limit problem, or does it look like a special one that we can use a rule for? Which special one is it? The original or the alternate? The original. And we're plugging in what number? Not a 0. A 3, right? So this says we're plugging in a 3, so the original function is going to be f of x is equal to ln of x plus x squared. Good call, whoever that was. Is that you, Neelish? Nice. Came from here. Ln of x plus x squared. What's the derivative of this? Very good, everybody. 1 over x plus 2x. And you have to plug in a what? Don't say 0. What this is a 3. So plug in a 3. You're going to get... There you go. Alright, we good? So the old thing used to be in the textbook. I made my own thing.